About 4 billion years ago, in the hot primordial ocean of our planet, something extraordinary appeared: life. From tiny, barely visible bacteria, after a long journey of billions of years, would come beings capable of reflecting on their origins, asking questions, and conquering the planet. Only 300,000 years ago, Homo sapiens, our own species, emerged. But why us? Why was it Homo sapiens that survived the ice ages, outcompete other ancient humans, and became the masters of the earth? Today, we will embark on a fascinating journey through eras full of dramatic events and astonishing transformations to uncover the greatest mystery: how and why we appeared. About 13.8 billion years ago, an event occurred that we now call the Big Bang. In that instant, all the matter that would later form the universe was compressed into an almost infinitely dense and hot state, known as a singularity. Within fractions of a second after the Big Bang, the universe began rapidly expanding and cooling, allowing the first elementary particles to form: protons, neutrons, and electrons. Just minutes later, the simplest atoms appeared, mainly hydrogen and helium. Around 200 million years after the Big Bang, the first stars began forming from gigantic clouds of gas under the pull of gravity. These earliest stars were extremely massive and consisted almost entirely of hydrogen and helium. They lived relatively short lives, and at the end of their cycles, they exploded as supernovae, releasing the first heavy elements into surrounding space. It was these stellar explosions that filled the interstellar medium with heavy elements, the very building blocks of planetary systems, including our own solar system. Earth formed about 4 billion years ago from a cloud of interstellar material orbiting the young sun. At first, our planet was a blazing sphere covered in oceans of magma and surrounded by a dense atmosphere of water vapor, carbon dioxide, methane, ammonia, and hydrogen sulfide. Frequent collisions with comets and asteroids gradually brought water and organic compounds to Earth's surface. Around 4.3 billion years ago, Earth cooled enough for water vapor to condense into liquid, creating the first oceans. It was in these oceans that one of the most pivotal events in the planet's history occurred: the origin of life. Modern scientists suggest that life arose as the result of complex chemical reactions among organic compounds dissolved in water. The energy for these reactions could have come from lightning, solar ultraviolet radiation, or heat from deep-sea hydrothermal vents, volcanic-like systems at the ocean floor. The first living beings were microscopic single-celled organisms without nuclei, called prokaryotes. They included bacteria and archaea, capable of surviving in extreme environments. The oldest undisputed fossils of such organisms, found in the rocks of Australia and Greenland, are about 3.7 billion years old. However, there are also more controversial findings, up to 4.1 billion years old, discovered in Canada and Greenland, whose classification as traces of life is still debated among scientists. About 2.5 billion years ago, a turning point occurred. The first cyanobacteria appeared, capable of photosynthesis. These organisms began releasing oxygen as a byproduct of their life processes. The large-scale accumulation of oxygen in the atmosphere, known as the Great Oxidation Event, began around 2.4 billion years ago. This process unfolded slowly over hundreds of millions of years, gradually enriching Earth's atmosphere with oxygen and creating the conditions necessary for the evolution of more complex and diverse life forms. Around 540 million years ago, one of the most significant and mysterious events in Earth's history took place: the Cambrian explosion. During this relatively short span of geologic time, about 30 million years, an enormous diversity of life forms appeared. Many organisms developed hard skeletons and protective shells for the first time. Before the Cambrian, life on Earth consisted mostly of single-celled organisms, simple algae, and primitive multicellular creatures such as sponges and jellyfish. But in the Cambrian, there was a true explosion of biological diversity and complexity in Earth's ancient oceans. Nearly all of the major animal groups known today emerged during this period. Arthropods, mollusks, echinoderms, the first vertebrate ancestors, and many others. One of the most famous symbols of the Cambrian explosion is the Burgess shale fauna, whose fossils were discovered in Canada. These extraordinary remains, preserved with remarkable detail, allow scientists to quite literally glimpse into the lives of organisms that inhabited ancient seas. Among them were truly bizarre creatures. For example, the predator Anomalocaris, which reached about 1 meter in length, resembled a giant shrimp and had unique spiny grasping appendages to catch prey. Another was Hallucigenia, a worm-like animal with long defensive spines on its back and thin legs below. Interestingly, scientists originally could not determine which way it was oriented and often depicted it upside down, though its true body structure is now understood. Yet another curious creature was Opabinia, a marine animal with 5 eyes and a long flexible proboscis. The reasons for such a rapid emergence of new life forms remain debated among scientists. Among the leading hypotheses are changes in the chemical composition of the oceans and the reaching of a critical oxygen threshold. Although oxygen levels had begun rising long before the Cambrian, but it was during this period that their concentration finally reached values necessary for the development and flourishing of complex multicellular animals. Another important factor is thought to have been the emergence of active predation, which triggered a kind of evolutionary arms race among animals, forcing them to develop protective shells, armor, and more complex body structures. The Cambrian explosion laid the foundation for the future evolutionary development of all multicellular life on Earth. Although many of the animals that appeared during this period later went extinct, it was then that the fundamental body plans were established, from which nearly all modern animals, and even our own distant ancestors, eventually evolved. About 375 million years ago, events occurred that would forever change the course of life's history on our planet. At this time, certain groups of fish began gradually leaving their aquatic habitats to explore land. Of course, this transition did not happen overnight. It required millions of years and many gradual changes to move from a fully aquatic lifestyle to life on land. The first vertebrates to conquer land were the early tetrapods, 4-limbed animals. Their ancestors were lobe-finned fish, such as Tiktaalik. This species already possessed strong fins similar to limbs, which it could use to push off the bottom and even briefly crawl onto land to move between bodies of water. Over time, these fins evolved into legs, and primitive lungs became increasingly efficient at extracting oxygen from the air. These animals laid the foundation for the later evolution of true terrestrial vertebrates. Then, about 320 million years ago, another crucial group emerged from early tetrapods, the amniotes. Their greatest evolutionary innovation was the amniotic egg, protected by a tough shell and filled with fluid, which allowed animals to reproduce completely independently of water and spread across a wide variety of terrestrial environments. Modern reptiles, birds, and mammals are all descendants of amniotes. The age of reptiles was made possible by the catastrophic Permian-Triassic extinction, which occurred around 252 million years ago and wiped out about 95% of all species on Earth. In the 20 million years that followed, the land was dominated by groups of reptiles such as therapsids, mammal-like reptiles and ancestors of mammals, and archosaurs, ancestors of dinosaurs and crocodiles. The first true dinosaurs appeared about 230 million years ago during the Triassic period. Over the next 150 million years, dinosaurs became the dominant animals on the planet, achieving astonishing diversity in form and size. There were giant herbivorous sauropods such as Diplodocus and Brachiosaurus, predatory theropods like the famous Tyrannosaurus and Allosaurus, and countless other extraordinary creatures. Importantly, although most dinosaurs eventually disappeared, one lineage survives and thrives to this day as their direct descendants. Modern birds are directly descended from small feathered theropods and, from a scientific perspective, are living dinosaurs. Yet, in the shadow of the dinosaurs, there had long existed small creatures destined one day to take their place: mammals. The first mammals appeared about 200 million years ago. They were very small, about the size of modern mice or shrews. For millions of years, they coexisted with dinosaurs, leading mostly nocturnal lives to avoid larger predators. Then, 66 million years ago, Earth was struck by a new catastrophe. An asteroid about 15 kilometers in diameter crashed into the region of modern-day Mexico, on the Yucatan Peninsula. The explosion was unimaginably powerful, triggering tsunamis, wildfires, and a global nuclear winter that lasted several years, blocking sunlight and drastically lowering the planet's temperature. This event, known as the Cretaceous-Paleogene extinction, proved fatal for most dinosaurs. Nearly all dinosaur species except birds went extinct. Paradoxically, this catastrophe cleared the way for small, modest mammals. With the disappearance of large predators and dominant herbivores, ecological niches opened up, and mammals quickly moved in to occupy them. A rapid evolutionary boom followed. Mammals grew larger, more diverse, and more numerous, spreading into virtually every ecosystem, from hot tropical forests to cold plains. An interesting fact: while life on land gave vertebrates many advantages, not all animals welcomed it. Some tetrapod lineages eventually decided, through evolution, to return to the water. This is how, around 50 million years ago, modern whales and dolphins descended from terrestrial ancestors. Their distant relatives gradually transformed their limbs back into fins and adapted once again to life in the oceans. Around 65 million years ago, as Earth slowly recovered from the global catastrophe, the age of mammals began. In this period, diverse animals filled the available ecological niches, and soon the first primates appeared, distant ancestors of modern monkeys and humans. These early primates emerged about 55 million years ago, at the beginning of the Eocene epoch. At that time, Earth's climate was much warmer and wetter than today. Vast regions were covered in dense tropical forests, and the average global temperature was about 14 degrees Celsius higher. This warm, humid environment was ideal for the flourishing of trees, vines, shrubs, and diverse plants, creating multi-layered, complex, and abundant ecosystems. It was within these tropical forests, among branches and thick foliage, that small animals the size of modern squirrels or little monkeys appeared, the first primates. These early primates were adapted to an arboreal lifestyle. They had flexible, grasping limbs with opposable thumbs, which allowed them to hold tightly onto branches, and long tails that provided extra balance while moving through the trees. Their eyes were positioned forward, giving them binocular vision, crucial for judging distances accurately when leaping between branches. They fed on fruits, flowers, leaves, and insects, all of which were abundant in these forests. Gradually, about 30 million years ago, Earth's climate began to change. Temperatures dropped, rainfall decreased, and tropical forests shrank while open landscapes such as savannas and woodlands expanded. These changes were especially pronounced in Africa, which became the place where the first primates began adapting to new living conditions. Around 20 million years ago, in the lush African forests, a special group of primates emerged, known as hominoids or apes. These creatures were closest to the evolutionary lineages that would one day give rise to humans. One of the best known was proconsul, which lived in what is now East Africa. Proconsul was medium-sized, about 1 meter long and weighing between 15 and 40 kilograms. In appearance, it was something between modern monkeys and great apes such as chimpanzees. Proconsul had no tail, bringing it closer to modern apes. Its arms and legs were long and strong enough to move confidently through branches on all fours. Its skull had pronounced jaws with large teeth, suited for a varied diet of fruits, leaves, and possibly small animals. Another important species was Dryopithecus, which lived from about 14 to 9 million years ago in Africa and Eurasia. This animal was larger than proconsul, weighing up to 40 to 50 kilograms. Dryopithecus more closely resembled modern great apes, such as chimpanzees and gorillas, thanks to their larger and sturdier build. Their limbs were well adapted for vertical climbing and upright movement among the trees, bringing them closer to modern great apes. Their teeth and jaws were powerful and well suited for chewing tough plant food typical of humid forests. The living conditions in the tropical forests of Africa at that time were nearly ideal for the development and flourishing of the first great apes. Dense canopies provided abundant food and shelter from large ground predators, while the stable warm and humid climate supported high numbers and diversity of animals. Gigantopithecus. Another astonishing creature that lived alongside ancient hominoids was Gigantopithecus, the largest ape known in the history of Earth. According to modern scientific data, Gigantopithecus appeared much earlier than previously believed, about 8 million years ago. They reached their peak in distribution and diversity around 2 million years ago, inhabiting mainly forested regions of southern and southeastern Asia. The size of Gigantopithecus was truly impressive. Standing on their hind limbs, they could reach about 3 meters in height, and an adult weighed between 400 and 600 kilograms. By both size and body mass, they greatly exceeded not only modern gorillas but all other primates that have ever lived on the planet. Outwardly, they resembled gorillas but were much more massive. Judging by fossil remains, they had strong jaws and enormous molars, perfectly suited for chewing coarse plant food such as bamboo, tree shoots, leaves, and fruits. Their massive teeth, several times larger than those of humans, are the main source of information for scientists, as almost all known finds consist of teeth and jaw fragments. Complete skeletons have not yet been discovered, making them even more mysterious creatures. Gigantopithecus were primarily ground-dwelling animals and moved on all fours, much like modern gorillas. They spent most of their time on the ground, though they could occasionally stand on 2 legs to reach high branches for fruit or foliage. This was a rare necessity rather than a habitual way of moving. These giant apes inhabited humid tropical and subtropical forests, where they could easily find sufficient food and shelter. Based on their jaw and tooth structure, they were exclusively herbivorous, preferring a fiber-rich diet. Gigantopithecus lived at the same time as several species of early hominins, including Homo erectus, who also inhabited Asia. Most likely, there were no direct conflicts between them, since they occupied different ecological niches and preferred different diets. Hominins were more omnivorous and used stone tools for hunting and food processing, while Gigantopithecus specialized exclusively in plants. However, about 100,000 years ago, Gigantopithecus completely disappeared. Scientists still debate the exact reasons for their extinction. The most likely factor was gradual climate change, which led to a reduction of the forested habitats they heavily depended on. Loss of habitat and shrinking food resources became fatal for these enormous primates. Additional factors may have included competition with other animals, including hominins, who were increasingly efficient at occupying new territories and exploiting resources, though this is not considered the main cause. Bipedalism. But about 7 million years ago, ancient hominins faced a new serious challenge. The Earth's climate was gradually becoming cooler and drier due to global geological processes such as mountain formation and changes in ocean currents. All this led to a significant reduction of dense tropical forests and the spread of more open landscapes. Savannas and woodlands. The thick forests that for millions of years had been the home and refuge of our tree-dwelling ancestors now quickly gave way to wide open plains covered with grass and scattered trees. These changes had a huge impact on the lives of early hominins, our distant ancestors. If earlier they could spend almost all their time in the trees, finding both food and protection from predators, now they were forced to adapt to entirely new living conditions. Open savannas no longer offered such reliable safety, pushing animals to move across the ground in search of food, water, and shelter. It was in these new conditions that our ancestors began gradually to stand on two legs. The earliest evidence of bipedalism is associated with ancient species such as Sahelanthropus and Ardipithecus, who lived about 6 to 7 million years ago. Their bipedalism was not yet as pronounced as in later members of our lineage, but even then anatomical adaptations for upright posture were beginning to form. The transition to bipedalism was not caused by a single factor but by several at once, and scientists continue to debate different hypotheses. One major idea is that it improved the ability to survey the open savanna, allowing hominins to spot predators and prey from a distance. Another important hypothesis is energy efficiency. Walking on two legs uses less energy over long distances than quadrupedal movement. Thermoregulation may also have played a role. An upright body position reduces exposure to direct sunlight, which was very useful in hot climates. Some researchers also suggest advantages in carrying food over long distances, wading through shallow water, or enhancing social interactions using free hands and gestures. Most likely, bipedalism arose as the result of a combination of all these factors. Another key advantage of upright posture was the freeing of the forelimbs. Hands could now be used for carrying food, infants, and various objects, greatly increasing survival and expansion into new territories. The ability to make and actively use stone tools emerged much later than the first signs of bipedalism. The oldest reliable traces of such tools belong to the so-called Oldowan culture, dating to about 2.6 million years ago. Of course, the transition to bipedalism did not happen instantly. It was a gradual process that took hundreds of thousands, or perhaps millions, of years. The first hominins that began to stand on two legs still retained the ability to move on all fours, especially when climbing trees or in situations that required maximum speed and maneuverability. However, over time, anatomical changes became increasingly pronounced and irreversible. The shape of the pelvis, the position of the spine, and the structure of the lower limbs gradually adapted to permanent bipedal locomotion. About 5 million years ago, among the bipedal hominins, beings appeared that bore a much stronger resemblance to us. Some of the most famous and important representatives of this group were the Ardipithecines and the Australopithecines. Ardipithecines lived about 4.5 million years ago in East Africa. The most well-known species is Ardipithecus ramidus, nicknamed Ardi. These creatures were short, about 120 centimeters tall, and weighed around 50 kilograms. Outwardly, they resembled both modern great apes and the first humans, combining features characteristic of both groups. Their brains were relatively small, about 350 cubic centimeters, roughly 3 times smaller than that of modern humans. Ardipithecines could already stand and move on 2 legs with some confidence, although their anatomy still showed that they spent a significant amount of time in trees. One of their most striking and unique features was the structure of their feet. The big toe was strongly splayed to the side, like in modern tree-dwelling apes, allowing them to grasp branches. Such a foot demonstrated intermediate traits between arboreal life and terrestrial bipedalism. Thus, Ardipithecines could walk on 2 legs on the ground, but did so less effectively and less confidently than later Australopithecines. Their arms were long and fairly strong, also indicating effective climbing ability and a strong grip on branches. Australopithecines appeared a little later, about 4 to 1 million years ago, and were more advanced hominins. The most famous species is represented by the discovery of the skeleton of a female nicknamed Lucy, about 3.2 million years old. The average height of Australopithecines was about 130 centimeters, and their weight ranged from 30 to 50 kilograms. They were stocky and robust, with broad pelvises and strong lower limbs, which allowed them to walk on 2 legs much more effectively and confidently. Their brains were also larger, though still about twice as small as that of modern humans. They lived primarily on the ground, though they did not completely abandon trees, using them especially for rest and protection from predators. Their diet was mostly plant-based fruits, seeds, roots, and leaves. However, Australopithecines were not strictly herbivorous but rather omnivorous with a predominance of plant foods. This means they could occasionally consume small animals, insects, and even carrion when available. Their teeth were massive, with large and strong molars, perfectly suited for grinding tough plant food. Life for early hominins was far from easy. In the open savannas, they faced threats from numerous predators such as saber-toothed cats, large hyenas, and giant predatory birds. To survive, they formed small social groups in which they cared for each other, defended themselves, and searched for food together. This lifestyle promoted the development of social skills, communication, and a gradual increase in intelligence. These species represent crucial stages in human evolution. Australopithecines are considered by scientists to be among the key candidates for the direct ancestors of the genus Homo, though the exact evolutionary links are still under active study and debate. Around 2.5 million years ago, a new hominin species appeared in Africa, Homo habilis, handy man, the first representative of our own genus. With this species begins a new era in human evolution, the age of stone tools and the first significant changes in lifestyle. Homo habilis was relatively short, about 100 to 140 centimeters tall and weighing 30 to 50 kilograms. Outwardly, they still resembled Australopithecines, but anatomically they were more advanced. The most notable difference was their larger brain volume, about 700 cubic centimeters, about 1.5 times larger than that of Australopithecines. This was the first major step toward increasing the intellectual abilities of our ancestors. The most important and unique achievement of Homo habilis, which made them famous, was the creation and use of the first stone tools. Archaeologists associate these tools with the so-called Oldowan culture, named after Oldoway Gorge in East Africa, where the first examples were discovered. The tools were simple, crudely chipped stone flakes, made by striking one stone against another. Despite their primitiveness, they were incredibly effective. With these tools, early hominins could butcher animal carcasses, break bones to extract nutritious marrow, process plant foods, and even defend themselves from predators. The diet of Homo habilis included not only plant foods but also a significant portion of animal meat, obtained through hunting or, more often, scavenging carcasses left behind by predators. Their main sources of food included small and medium-sized mammals such as antelopes, gazelles, hares, as well as various birds and reptiles. They had to compete for food resources with other hominins, such as Paranthropus, large herbivorous Australopithecines, as well as with various predators and scavengers, including large hyenas, saber-toothed cats, and vultures. Life in the African savannas at that time was dangerous and difficult. Predators constantly threatened small groups. For this reason, group living, social cooperation, and the development of tool use became the most important survival strategies. Living in small groups of 10 to 20 individuals, Homo habilis could defend themselves more effectively and find food more successfully. Their social organization already showed early forms of division of labor. Some searched for suitable stones to make tools, others butchered carcasses, still others guarded the group or collected plant food and water. In this way, early humans maximized available resources and reduced risks associated with obtaining food. At that time, Homo habilis had not yet discovered fire or learned to maintain constant campfires, so nighttime remained especially dangerous. With the onset of darkness, they sought shelter among large rock outcrops, avoiding encounters with nocturnal predators. However, hominin evolution did not stand still. Around 1.9 million years ago, a new, significantly more advanced species appeared in Africa, Homo erectus, upright man. This marked the next major step toward modern humans, and with this species began a new era, when our ancestors started confidently conquering not only surrounding territories but even new continents. Homo erectus differed significantly from their predecessors, above all in height and body build. The average height of an adult was about 160 to 180 centimeters, making them noticeably taller and slimmer. Their weight ranged from 50 to 70 kilograms, and their body proportions were already close to those of modern humans. The brain also continued to grow, reaching a volume of 800 to 1,000 cubic centimeters. One of the main and revolutionary achievements of Homo erectus was the mastery of fire. Around 1 million years ago, these ancient humans learned not only to use fire from natural sources such as wildfires and lightning strikes, but also to maintain it, and eventually to create it on their own. This innovation completely transformed their way of life. Fire provided warmth, protection from predators, and the ability to process food. Cooked food was easier to chew and digest, allowing them to obtain much more energy and nutrients. This, in turn, contributed to further brain growth and overall development. Homo erectus were also the first true travelers. Around 1.8 million years ago, they began leaving the African continent and settling in other regions of the planet. This was the first major migration wave of hominins out of Africa, marking the beginning of humanity's global dispersal. The first new regions reached by Homo erectus were areas of modern-day Georgia, China, and Southeast Asia. The oldest finds confirming their presence outside Africa were discovered in Dmanisi, dating to about 1.8 million years ago. Later, Homo erectus reached China and the islands of Indonesia, and eventually spread across other regions of Eurasia, including parts of modern Europe. These incredibly long and difficult journeys through diverse climate zones were made possible by their high adaptability, mastery of fire, use of primitive tools, and growing social skills. They traveled in small groups, closely cooperating in obtaining food, building shelters, and defending against threats. Homo erectus were also the first to create relatively complex stone tools belonging to the Acheulean culture. Their famous Acheulean hand axes, carefully crafted stone tools with sharp edges, became versatile instruments for hunting, butchering, gathering, and building shelters. These tools allowed them to obtain food more efficiently and to adapt to harsher living conditions in different parts of the world. However, global migration was not without difficulties and dangers. They encountered new predators and harsh climates, especially in colder regions of Eurasia. In Europe, they had to coexist with large predators such as cave bears and lions, while also hunting large herbivores such as deer, bison, and even elephants in order to sustain themselves. Their ability to maintain fire and use it for warmth and protection was a crucial factor in survival under such challenging conditions. Milankovitch cycles. About 2.5 million years ago, Earth entered a period of dramatic climate change known as the Pleistocene epoch. The onset of the ice ages was caused by a combination of natural factors, especially the Milankovitch cycles, regular, repeating variations in Earth's orbit around the Sun and the tilt of its axis. These cycles are named after the Serbian scientist who first described their effect on the planet's climate. The Milankovitch cycles include three main components. The first is the change in the eccentricity of Earth's orbit around the Sun. The second is the change in the tilt of Earth's axis relative to the orbital plane, which varies between about 22 and 24.5 degrees over a cycle of roughly 41,000 years. The third component is precession, the slow wobble of Earth's axis, with a period of about 26,000 years. These periodic changes altered the amount of solar energy reaching different regions of the planet at different times of the year, leading to cycles of global cooling and warming. Combined with fluctuations in solar activity and changes in ocean currents caused by tectonic plate movement, these processes had a profound impact on Earth's climate. As a result, the planet cooled significantly, entering an era of long glacial periods alternating with relatively short warm periods. Vast areas of North America, Europe, and Asia were covered by thick ice sheets, while global sea levels dropped significantly due to the immense amount of water locked in glaciers. These dramatic climate changes greatly affected plants and animals. Expansive forests and lush jungles retreated, giving way to cold steppes, tundras, and open plains covered with tough grasses and shrubs. This shift in landscapes brought about a transformation in animal life as well. Warm-adapted species were replaced by animals suited to harsh conditions, such as mammoths, woolly rhinoceroses, giant deer, reindeer, and bison. Alongside them appeared large predators such as cave lions, giant hyenas, and saber-toothed cats. In these new environments, early hominins faced new challenges that required significant adaptations. Homo heidelbergensis. Around 800,000 years ago, a new species of ancient humans appeared in Europe and Africa. Homo heidelbergensis. This species is considered by most scientists to be the direct ancestor of both Neanderthals and modern humans. Homo heidelbergensis already looked very similar to us. Adults reached a height of about 170 centimeters, had strong, robust builds, and large brains, nearly the size of that of modern humans. Their faces were broad and heavy, with prominent brow ridges, wide nasal openings, and projecting jaws. However, compared to earlier species, their features were already much more refined. One of the most important traits of Homo heidelbergensis was their ability to effectively hunt large animals. Using advanced stone tools, they hunted large herbivores such as bison, large deer, horses, and even elephants and rhinoceroses. Such hunting required not only strength and agility, but also complex collective actions, coordination, and a high degree of social organization. In addition to hunting, they actively gathered fruits, nuts, seeds, and plant roots, supplementing their diet and providing their bodies with important nutrients. At this time, the first signs of systematically organized dwellings appeared, usually located near water sources and food supplies. To protect themselves from cold and predators, Homo heidelbergensis built simple shelters using tree branches, large animal bones, hides, and stones. Archaeological findings show that some groups regularly returned to the same sites, indicating the beginnings of a sedentary lifestyle. One of their most important skills was the use and maintenance of fire. They built campfires for cooking food, protection from cold, lighting, and keeping predators away. This gave them a tremendous advantage, as it allowed them to settle in more northern regions of Europe, where survival without fire would have been nearly impossible. Homo heidelbergensis is considered a key link between earlier members of the genus Homo and later species, including Neanderthals and modern humans. Around 400,000 years ago, in Europe, a new species of ancient humans appeared, one of the most mysterious and well-known of our relatives, the Neanderthals. Neanderthals first appeared in Europe and later spread into western parts of Asia. The earliest remains of early forms of Neanderthals date to about 350,000 years ago. However, the typical classic Neanderthals, with their distinct anatomical features, developed later around 200,000 years ago. These ancient hominins were well adapted to the harsh conditions of the ice ages and became one of the most advanced forms of humans ever to exist before the emergence of modern humans. Neanderthals were strong and physically powerful. Their average height was about 160 centimeters, and their weight could reach 80 kilograms or more. They had powerful musculature, wide rib cages, strong short limbs, massive skulls with prominent brow ridges, and noticeably projecting noses. These physical traits helped them retain heat and survive effectively in the cold climates of Europe and Asia during the Ice Ages. The brains of Neanderthals were very large, even slightly larger than those of modern humans. However, a larger brain does not necessarily mean greater intelligence. Despite the size, the internal structure of the Neanderthal brain was somewhat different, which may have influenced their way of thinking, perception of the world, and behavior. Nevertheless, their high level of brain development was reflected in their culture and lifestyle. The culture of Neanderthals was surprisingly advanced and diverse. They actively used sophisticated stone tools belonging to the Mousterian culture. These tools were more advanced and specialized than those of their predecessors. Neanderthals crafted spear points, knives, scrapers for working hides, hand axes, and other multifunctional tools. They selected the highest quality stones, such as flint, quartzite, and obsidian, and carefully shaped them to achieve sharpness and durability. One of the most remarkable qualities of Neanderthals was their hunting efficiency. They were masters of collective hunting, skillfully driving and killing large animals such as mammoths, woolly rhinoceroses, and even cave bears. Such complex activities required not only physical strength and skill, but also the ability to coordinate within the group, plan, and use strategies. They used spears and, according to some evidence, throwing weapons which greatly increased their effectiveness and safety. Another unique feature of their culture was their burial rituals. Archaeologists have found numerous pieces of evidence that Neanderthals deliberately buried their dead. They dug graves, placed bodies in specific positions, and sometimes sprinkled them with red ochre pigment, possibly symbolizing life or rebirth. There is also evidence that Neanderthals sometimes placed flowers or various objects in graves, which may have had symbolic meaning. This suggests a high level of spiritual development, an awareness of mortality, and the capacity to reflect on the possibility of an afterlife. They also demonstrated a strong level of social organization and mutual support. Archaeological evidence shows that they cared for the sick, injured, and elderly members of their groups, helping them survive and providing care even when those individuals could no longer hunt or fend for themselves. Such social cooperation required emotional and social intelligence, empathy, and an understanding of the importance of communal bonds. However, around 40,000 years ago, Neanderthals began to gradually disappear. By about 35,000 years ago, the species had completely gone extinct. The reasons for their disappearance remain the subject of intense scientific debate. One of the most widespread hypotheses is that their extinction was caused by a combination of factors. First of all, around 50,000 years ago, members of our own species, Homo sapiens, began migrating out of Africa into Europe and Asia. Modern humans possessed several competitive advantages, including more advanced technologies and weapons, a wider variety of hunting and gathering strategies, and more complex social and cultural structures. As a result, Neanderthals faced stiff competition for land and resources, gradually losing ground. Another important factor was likely climate change at the end of the last ice age. These changes may have reduced the populations and migration routes of the animals Neanderthals hunted, making survival more difficult and forcing them to move in search of new food sources. Finally, recent genetic research has confirmed that Neanderthals and modern humans interbred, resulting in the gradual absorption of Neanderthal genes into the human population. Today, modern humans living outside Africa carry between 1% and 4% of Neanderthal DNA, showing that their disappearance was not only due to extinction, but also through gradual mixing with Homo sapiens. Homo sapiens, the emergence of intelligence. The first Homo sapiens appeared around 300,000 years ago in Africa. The oldest remains of our species have been found in Morocco, Ethiopia, and South Africa. These discoveries show that our earliest ancestors already had many traits typical of modern humans. A relatively high forehead, a rounded skull, finer facial features, and a less robust body compared to earlier species, although some more archaic traits remained. Homo sapiens evolved from earlier African hominins such as Homo heidelbergensis. About 800,000 years ago, there existed a common ancestor of three species: Homo sapiens, Neanderthals, and Denisovans. From this ancestor, one evolutionary branch led to the emergence of Homo sapiens in Africa about 300,000 years ago, while another branch, developing in Eurasia, gave rise to Neanderthals and Denisovans. Thus, Neanderthals and Denisovans were more closely related to each other, while sapiens represented a separate evolutionary line. The key distinction of sapiens was a unique type of thinking and the ability for abstract perception of reality. Already about 100,000 years ago, they created sophisticated tools, ornaments, and symbolic objects such as beads made from seashells and ostrich eggshells. These artifacts reflect not just a pursuit of beauty, but also the formation of symbolic concepts and perhaps spirituality. Archaeological excavations in Africa and the Middle East have uncovered many remarkable finds that illustrate the everyday lives of our ancestors. For example, in Blombos Cave in South Africa, ancient ornaments about 75,000 years old, carefully crafted from seashells, have been discovered. Pieces of ochre with geometric carvings were also found there, some of the earliest evidence of human abstract creativity. In Israel's Skull Cave, remains of ancient Homo sapiens dating to around 100,000 years ago were discovered. These finds prove that humans left Africa quite early, although large-scale migration began later. In the same region, remains of ancient dwellings and numerous stone tools have been uncovered, showing prolonged and successful settlement of new territories. Another fascinating find was made in Kafza Cave, also in modern-day Israel. Bodies of the dead were carefully laid in graves, decorated with ochre, and accompanied by specially selected objects. This indicates that even then, our ancestors showed respect for the dead, had strong social bonds and symbolic thinking. Humans also began to use increasingly complex and specialized tools such as arrows, needles, sewing implements, and even the first musical instruments. At this time, cave art also flourished, becoming a vivid expression of the creative and aesthetic abilities of our distant ancestors. Thanks to their unique intellectual abilities and social cooperation, Homo sapiens were able to successfully adapt. The Great Migration out of Africa, able to adapt to nearly any environment. Around 60,000 years ago, the second and largest wave of Homo sapiens migration out of Africa began. Our ancestors rapidly began to settle in Eurasia, Australia, and much later the Americas. These migrations led to Homo sapiens becoming the only human species on the planet, gradually displacing or assimilating their ancient relatives. During this expansion, our ancestors encountered other human species that had long inhabited Europe and Asia. Among them were the well-known Neanderthals and the lesser-known but highly mysterious Denisovans. As previously mentioned, Neanderthals had already been established in Europe and Western Asia long before Homo sapiens arrived, so their encounters could not have gone unnoticed. For roughly 15,000 years, the two species coexisted in some regions, sometimes competing for resources and at other times interacting peacefully, even interbreeding. As a result of these contacts, modern humans of non-African descent inherited between 1% and 4% of Neanderthal genes, which continue to influence our immune system, skin, hair, and certain other traits. Even more fascinating and mysterious were the Denisovans. These ancient humans were only recently discovered, thanks to astonishing finds in Denisova Cave, located in the Altai Mountains of Russia. The first discovery was made in 2008, when archaeologists found a fragment of a finger phalanx belonging to a girl who lived about 50,000 years ago. Analysis of her DNA caused a scientific sensation. It turned out to be a completely new type of human, previously unknown to science. Despite this important discovery, very little is known about Denisovans. From the recovered fragments of bones and teeth, it can only be concluded that they were anatomically similar to Neanderthals but genetically distinct, and likely of relatively short stature, around 150 centimeters tall. Genetic analysis indicates that Denisovans and Neanderthals split from a common ancestor roughly 400,000 years ago, evolving along separate paths and occupying different territories. The Denisovan culture also remains poorly understood. Some archaeological evidence, however, points to its exceptional complexity and uniqueness. In Denisova Cave, researchers found not only stone tools but also remarkable works of art and ornaments. Among these is a famous bracelet made of green chloridolite, crafted with extraordinary skill about 50,000 years ago. The drilling technique used to make holes in this bracelet was so precise that it required a high level of craftsmanship and tools that scientists had not expected to exist for such ancient humans. This discovery reshaped ideas about Denisovan cultural abilities, showing that they possessed sophisticated skills and an aesthetic sense. How exactly Denisovans spread across Asia and reached distant regions, such as the islands of Oceania, remains one of the intriguing mysteries. Given that their genes have been found even among inhabitants of Southeast Asian islands, Denisovans, or their descendants, may have used primitive watercraft to cross straits and colonize islands. Whether direct conflicts occurred between Homo sapiens and other human species remains unknown. No direct archaeological evidence of such conflicts has been found, though some indirect signs suggest possible tensions and encounters. For example, there are traces of injuries on Neanderthal and early Homo sapiens bones, although it is impossible to determine whether these were caused by interspecies clashes or internal conflicts. Nevertheless, competition for limited resources, such as hunting grounds and caves, could certainly have led to aggression and localized confrontations. Encounters between Homo sapiens and Denisovans, as well as Neanderthals, involved not only competition for territory and resources but also periods of coexistence and even interbreeding. This was particularly pronounced in Asia and Oceania. Modern inhabitants of Australia, New Guinea, and some Pacific islands carry up to 6% Denisovan DNA. These genes helped our ancestors adapt to new living conditions, including survival at high altitudes and adaptation to local climates and diseases. However, despite such interactions, Denisovans disappeared completely around 30,000 years ago, likely due to competition with Homo sapiens, climate changes, and gradual assimilation through interbreeding. Another remarkable ancient human species were the hobbits of Flores Island, scientifically known as Homo floresiensis. These extraordinary humans stood out among other ancient members of the human genus. They were astonishingly small. Adults rarely exceeded 1 meter in height and 25 to 30 kilograms in weight. Their brain volume was extremely small, about 400 cubic centimeters, comparable to that of Australopithecus. Despite their modest brain size, these diminutive humans demonstrated notable intelligence and adapted successfully to the challenging conditions of island life. The first hobbit remains were discovered in 2003 in Liangbua Cave on Flores Island. The most famous find was the skeleton of an adult woman, nicknamed Flo later. Remains of several other individuals were uncovered, along with stone tools, hearths, and the bones of animals hunted by these humans. This confirmed that Homo floresiensis was not an accidental anomaly but a distinct, well-adapted species that thrived on the island for tens of thousands of years. The uniqueness of Flores humans can largely be explained by island dwarfism, an evolutionary phenomenon where limited space and resources lead to smaller body sizes. At the same time, the island also fostered gigantism in some species. Giant rats the size of small dogs, enormous storks over 1.5 meters tall, and dwarf elephants, stegodons, comparable in size to large bulls, coexisted with miniature humans. Despite their small stature and limited resources, the hobbits successfully hunted stegodons and other large animals, a complex activity requiring coordination, teamwork, and strategy. Their diet also included a variety of plants, small animals, birds, and abundant marine life along the island's coast. Hobbits crafted stone tools, maintained fire, and built simple shelters. They led complex social lives necessary for survival in confined spaces and amidst dangerous predators and large animals. The exact reasons for their disappearance remain unclear, but it is likely that around 50,000 years ago they faced climate changes, resource depletion, or competition from arriving Homo sapiens, who may have played a role in their ultimate extinction. Regardless of the unanswered questions, the Flores hobbits remain one of the most extraordinary examples in the study of human evolution under complete geographic isolation. Around 12,000 years ago, the last ice age ended, and the Earth's climate became noticeably milder and warmer. As glaciers melted, vast areas were covered with green plains, dense forests, and fertile soils. It was during this period that one of the most important events in human history began, the Neolithic Revolution. The Neolithic Revolution marked the transition from nomadic hunter-gatherer life to settled communities based on agriculture and animal husbandry. This transformative process occurred gradually over hundreds or even thousands of years and first began in the Fertile Crescent, a region of the Middle East encompassing modern-day Turkey, Syria, Iraq, and Israel. The shift to agriculture was not a sudden invention but the result of long and gradual observation of the natural world. People noticed that seeds planted in the ground would sprout and produce new crops. Gradually, they began selecting and deliberately sowing the most productive varieties of plants, such as barley, wheat, lentils, peas, flax, and various legumes. Around the same time, humans began domesticating animals, starting with dogs, which descended from tamed wolves and became loyal companions in hunting, protection, and daily life. Soon after, goats, sheep, and cattle were domesticated, providing not only meat but also milk, wool, hides, horns, and bones for making various tools and objects. Pigs were among the first domesticated animals as well. They reproduced quickly and were easy to care for, offering a reliable source of food. These changes in lifestyle triggered a true revolution in daily life. Whereas hunter-gatherer life had been full of uncertainty, risk, and constant movement in search of food, people now had the opportunity to create permanent settlements and store surplus food. The first permanent villages, such as ancient Jericho and Catalhoyuk in Anatolia, around 9,000 years ago, became centers of prosperity, craftsmanship, and trade. Life in these settlements changed dramatically. People began constructing sturdy houses from clay and stone, building granaries and food storage facilities, and creating basic irrigation systems for their fields. With the advent of food surpluses came labor specialization. Some people focused on farming, others on animal husbandry, while others became skilled craftsmen, producing pottery, leather goods, textiles, and stone tools. Merchants emerged, trading goods between settlements and even distant regions. The development of agriculture led to a significant increase in population. With more stable food supplies, communities could support more people. Hunter-gatherer groups of a few dozen individuals gave way to villages and small towns with hundreds or even thousands of inhabitants. This concentration of people fostered a more intense exchange of ideas and technologies, giving a powerful boost to the development of civilization. One of the clearest indicators of the success of the Neolithic Revolution comes from archaeological findings at Catalhoyuk in Turkey. Here, archaeologists discovered houses built close together without streets, with entrances through the roofs. Inside these homes, people created magnificent wall paintings depicting hunting scenes, the domestication of animals, and early symbolic imagery, reflecting the beginnings of religious and mythological thought. Figurines of women were likely symbols of fertility and motherhood. Ritual horns built into the walls may have held ceremonial significance. However, the shift to settled life also had its darker sides. People were now exposed to the spread of infectious diseases transmitted from domestic animals. Living permanently in large settlements facilitated epidemics that had previously been rare among small hunter-gatherer groups. Additionally, conflicts over land and resources emerged, leading to the first signs of organized violence and warfare. Archaeological excavations confirm cases of violent deaths, showing characteristic injuries consistent with armed confrontations between settlements. Despite the challenges and problems caused by the transition to agriculture, the Neolithic Revolution was a pivotal event that shaped the entire subsequent history of humanity. It made the development of large cities, complex civilizations and intricate cultures possible, and, ultimately, the formation of modern society. One of the main factors that made us who we are today was our remarkable ability to create and transmit complex ideas and knowledge. This was greatly aided by the emergence and development of language, art, and symbolic thinking. The earliest traces of conscious symbolism appeared long before the advent of agriculture and early civilizations, roughly 50,000 years ago. Even then, our distant ancestors adorned their bodies with shell necklaces, beads made from ostrich eggs, and other meaningful objects. But the true pinnacle of ancient symbolic creativity was the emergence of the first cave paintings. The most famous examples of ancient cave art are found in the Altamira caves in Spain and Chauvet Cave in France. Many of these images date back roughly 40,000 years. On the walls of these caves, ancient humans depicted realistic hunting scenes and figures of animals. Additionally, there are representations of human figures, handprints, and mysterious abstract symbols, the meaning of which remains a subject of scientific debate. These paintings impress not only with their artistic beauty and realism, but also with the depth of perception that ancient humans had of the world around them. Natural mineral pigments were used to create these images, mixed with water or animal fats. Some paintings were applied with fingers or simple brushes made from twigs and animal hair. Others were created using special tubes, through which the artists sprayed pigment onto the walls. However, cave art was not merely a way to decorate caves or record memorable events. Many researchers believe that these paintings were part of complex rituals and ceremonies related to hunting, expressing early religious and mythological ideas of our ancestors. This represented a crucial step in the development of human consciousness, allowing people to understand the world through symbols, metaphors, and images. The emergence of the first myths and religions was a natural continuation of this process. The complex world around humans demanded explanations. Why the seasons change, how humans and animals came into being, and what happens after death. Ancient people found answers in myths filled with images of gods, heroes, and magical beings. One of the earliest known examples of ritual and religious life is the Göbekli Tepe temple complex in present-day Turkey, estimated to be about 12,000 years old. At this remarkable site, massive stone pillars adorned with animal reliefs and abstract symbols were discovered, clearly serving religious or ritual purposes. This temple is a striking indication that ancient humans already possessed not only advanced consciousness but also the ability to organize collectively to build such complex and large-scale structures. The development of complex myths and religions played a key role in uniting human communities. Shared beliefs and rituals strengthened social bonds, created a sense of community and collective identity, and eventually led to the formation of the first social institutions and cultural traditions. Thanks to the growth of symbolic thinking, language, and art, humans were able to accumulate and transmit knowledge across generations. Gradually, oral transmission of traditions gave way to early attempts at recording information on clay tablets and stone slabs. About 5,000 years ago, the first writing systems emerged: cuneiform in Mesopotamia and hieroglyphs in ancient Egypt, marking the starting point of history as we understand it today. With writing, humanity gained the ability to preserve information about the past, record laws and agreements, track harvests and trade, and document legends and myths. This paved the way for the rise of the first advanced civilizations and cultures, forming the foundation of modern society. Conclusion. Thus, our incredible journey comes to an end. We began with the Big Bang, when all matter and energy in the universe were concentrated in an almost infinitely dense and hot state. Since then, about 13.8 billion years have passed. If we imagine the entire history of the universe as 1 hour, all life on Earth would have appeared in the last few seconds, and human civilization in just a moment before the end of that minute. Despite this incredibly short span of time, life has undergone an extraordinary journey. From the first primitive organisms and strange creatures of the Cambrian period to mighty dinosaurs and ancient mammals, from small ape-like humans to the remarkably adaptive and creative people of today. Each stage of this journey has been marked by struggle, victories, and defeats, astonishing discoveries, and constant change. The most remarkable aspect of this story is that evolution never stops. It is happening right now in ourselves and in the world around us. We continue to change and develop under the influence of our environment, culture, and technology. Today, humanity is not only subject to natural selection, but for the first time in history, we are capable of consciously influencing our own evolution. Genetics, biotechnology, and artificial intelligence open up incredible possibilities while simultaneously placing a tremendous responsibility on us for the future of our species. What will our next stage of development be? No one knows for sure, but one thing is certain. The amazing journey that began with the first living cell and led to the creation of the most complex civilizations and cultures will continue, revealing new and exciting horizons before us. Thank you for watching. If you enjoyed this video, don't forget to like and subscribe to the channel so you won't miss new fascinating lectures. Share your thoughts in the comments and tell us what topics you'd like to hear about in future videos.